and welcome to our channel. Today, we greet you from our new Tbilisi office. My name is still Dmitry, and I'm a part of the Exactpro research team. At our new Exactpro office, we continue to build software to test software. As always, I want to encourage you to check out our website for more information about us. And don't forget to subscribe and hit that bell button to make sure that you see the upcoming videos. We are continuing our series based on the ISTQB Certified Tester AI testing syllabus. Today, we will go over Chapter 6, called Machine Learning, Neural Networks, and Testing. In our previous videos, we have broken down machine learning workflow and introduced classical machine learning models. But sometimes, classical machine learning models can solve the task at hand with sufficient accuracy, which is something that the human brain is capable of. So, to implement this, researchers moved on to more complex models, neural networks. A deep neural network is useful when you need to replicate human labor with autonomous work without losing its efficiency. In a nutshell, the idea behind the technology was to replicate the functioning of the human brain, represented here as a multitude of linked neurons. In 1943, McCulloch and Pitts developed a computer neural network model based on mathematical algorithms and the theory of brain activity. They proposed that neurons could be thought of as devices that operate with binary numbers and called this model threshold logic. They presented a network of electronic neurons and demonstrated that it could perform virtually any imaginable numerical or logical operation. In 1957, Rosenblatt developed mathematical and computer models of the brain's perception of information based on a two-layer learning neural network. This network trained using the arithmetic operations of addition and subtraction. This was one of the first examples of a neural network called the single-layer perceptron, which could be used to decide if an input belonged to a particular class or not. In 1969, the idea of neural networks was harshly criticized by Minsky and Pipert. They pointed out serious problems that hindered the effective use of artificial neural networks. For example, they drew attention to the impossibility of implementing the exclusive OR function in neural networks, as well as pointing out the insufficient computing power available back then. This article undermined the interest in neural networks for some time. However, the field was still of interest to many researchers. Computers improved, computing power increased, scientists solved the exclusive OR problem, making advances in the field more and more realistic. Which brings us to the multi-layered neural networks of today. Deep neural networks. So one more time, a neural network is made up of neurons that are linked by layers and connections between them. A neuron is a computing unit that receives information, performs simple calculation on it, and passes it on. Neurons are combined into three types of layers. The input layer receives inputs, and the output layer provides predictions. Between input and output layers lie hidden layers made up of artificial neurons, which are also known as nodes. A synapse is a connection between two neurons. A characteristic of a synapse is its weight. It makes the input information change when it is passed from one neuron to the next. Let's say there are three neurons which transmit information to the next one. Respectively, we have three weights corresponding to each of these neurons. The neuron that has the heavier weight will be the dominant information in the next neuron. The computations are performed by each neuron except for those in the input layer, and as a result, we get activation values. These values are calculated by running the activation function that receives values from all neurons in the previous layer and brings them to a certain range. It then assigns the weights to the connections between the neurons and the individual bias of each neuron. Note that the bias we're talking about here is some predefined constant value and not the degree of prejudice we talked about in the earlier videos. Running different activation functions can result in different activation values. These values are typically centered around 0. They have a range between -1, meaning that the neuron is disinterested, and +1, meaning that the neuron is very interested. During training, each neuron is preset to a bias value, and the training data is passed through the network activating functions in every neuron, which generates outputs. These outputs are then compared with the known correct results. For example, label data. The difference between the actual output and the known correct result is then fed back through the network to modify the values of the weights on the connections between the neurons in order to minimize the difference. This process is called backpropagation. As more training data is fed through the network, the weights are adjusted as the network learns. This continues until the outputs are considered good enough to end training. So where can you find neural networks? When it comes to finances, neural networks can help us in the areas of banking and credit risk, and market investment and fraud. The first one contains credit risk predictions and macroeconomic predictions. The second one consists of financial predictions, stock trading, and portfolio management. And the third one has fraud predictions and detection. If we talk about financial predictions, artificial neural networks allow us to forecast the exchange rates, stock movements, and prices based on the historical data and the information extracted from the market news. For example, they can be applied in stock trading for buy, sell, hold forecasts, where stocks are traded separately using the daily close prices. Companies such as MG Futures and Bridgewater are working towards fully realizing the potential of networks in stock market prediction. Over a 2-year period, MG Futures reported a 199.2% return due to the use of neural network prediction methods. Another area of focus is macroeconomic predictions and credit risk, which plays a crucial role for the financial institutions. The solutions to this problem are based on the analysis of historical data. And again, the most accurate models for these issues are deep neural networks. Deep learning can also be leveraged to benefit portfolio building. Namely, neural networks are used to forecast the returns on assets and to minimize the investment risk. As technology advances, more importance is placed on online transactions. But at the same time, ways of committing financial fraud are also becoming more sophisticated. Luckily, artificial neural networks can help to keep our finances safe. Deep learning and artificial neural networks applications are powering systems capable of detecting all forms of financial fraud. These applications can identify unusual activity, for instance, a transaction occurring outside the established time frame. This allowed Visa to cut credit card fraud by 2/3 by analyzing information such as payment method, time, location, item purchased, and the amount spent. Even a small deviation from the norm in any of these categories can highlight a potential fraud case. Smart solutions allow Visa to look at over 500 data elements to determine if a transaction is suspicious. But still, it can make it very embarrassing if the card is declined by a retailer by mistake. As we can see, neural networks are used to solve rather critical problems. This is why it is especially important to test them. And that is it for video number 6. If you liked it, give us a thumbs up. In the next one, we'll be talking about Chapter 7, which is about testing AI-based systems. As always, let me remind you that we do have a ton more awesome videos on our channel, so feel free to subscribe and hit that bell button. Thanks for watching, and see you soon.